Okay, perfect. Um, well, I'll go ahead and get started. Well, welcome everyone to the Java official workshop. I'm so happy to have you all here and to learn the best language of all time, Java. My name is Azhar, and I am the president of DSC, and I am joined by Mr. Clementine Bo. He's a Java tech lead here at DSC FIU. And yeah, we're going to talk to you guys about Java. And in additional, if you're new to programming, this will be a great first start for you to learn how to program. This event is in collaboration with our beautiful friends at DSC, or sorry, at AIS FIU as well, where they will talk now about their chapter at FIU. Go ahead.
Thank you. Hey guys, my name is Eduardo Guzman. I am the president of Association for Information Systems. We're a club that focuses on business and technology. We are actually part of the business department. However, we love to code, we love to analyze data, we love anything about those things. And our mission is to basically give our members the necessary tools to become perfect professionals in not only in the business area but also in the tech area. So if you're into both those two things, I recommend you to join and see our sessions. We have multiple programs, the business analytics experience, which is basically what we're doing here, um, where we give our members the opportunity to learn new technologies such as Java in this case, which is a programming language. We have professional developments, we have blockchain workshops. We have a competition happening this semester, which is a business case. And then the other one is going to be a datathon that later on I'm going to let you guys know about it. We have a community network, and also we have data talks with professional with professional experts in the fields, and also women in tech talks where we have professionals also in that area that promote how the women in the tech field. Next slide, please. So tomorrow we're gonna sorry, on Friday we're gonna have our executive lunch with Capital One. Basically we're gonna have analysts coming to our sessions, to our Zoom session. It's gonna be at 12 at noon. If you are interested, go to go.fiu.edu/Capital One. This is a great opportunity just to network with the recruiters and some workers that actually work in the field. And if you're interested to become an analyst, this is a better opportunity to see those things. Now I like to change my to pass it around to Azhar and Clementine. Please enjoy this workshop. These guys are amazing. One of them is a Java Knight and the other one is a Java Evangelist and a backend developer from Underline. So yeah, enjoy it.
Perfect. Thank you so much, Eduardo. Let's go ahead and get started. So, who are we? Who are the people talking right now? Well, my name is Azhar. Like I mentioned, I am the president at DSCFIU. I'm a junior studying mathematics and computer science. I am an upcoming intern at FB this summer. I primarily do Android development, which is in Java. And please, I am coming out with my course. Please sign up for it. It will be worth $9,999.99 for you guys. Now are getting the free trial. So I hope you all enjoy. Um, yeah, and now Clement.
Hey guys, my name is Clement Bo. I'm the competitive programming tech lead at FIU, at DSC FIU, also mostly known as like the Java tech lead. I'm a junior. I major in computer science. I work in Android and web development. I am a Java evangelist, and yeah, I will be making sure that I secure all of your first payments by the end of this workshop.
Perfect. Thank you so much, Clement. And without further ado, let's go ahead. Kelsey, you're not going to regret this. Let's go ahead and get started. So, what do we have to talk about today? Well, our overview as a whole, we're going to be covering a general overview of Java, and then we'll get into how you can print statements and whatnot in Java. So if you want to print so that everyone could see your code or what you want for the print out, that will be a part of the output section. Variables essentially will be how you store pieces of information and how you can access it. Functions will be able with functions you'll be able to write large pieces of code and you'll be able to run them and test them to get specific results. Conditions essentially will allow for you to if something based on a certain event or a certain action, you'll be able to make another action based on that first event. Loops, being able to iterate or being able to go through a certain set of numbers or a certain length or a certain amount of numbers. That will essentially be loops and data structures, as it is with the name. That is part of the way how you'll be able to store information. So whether that includes arrays, hash maps, hash sets, all of that sorts. That is the full length of the material that we'll be covering today. Uh, yeah, so first we'll be giving a quick overview. So what is Java, right? What is Java? Java is a programming language, and essentially it was released by Sun Microsystems in 1995. Right now, Java is owned by Oracle, and they make updates to the language and whatnot. There are plenty of applications and websites that are that run with Java. Um, and including like the JDK or the Java Developer Kit on your computer, or some other, a bunch of other programs. And as of recent, some programs on the internet that ran with Java recently got shut down. But don't mind that. Java is still supreme, and there's also a whole bunch of development that is going on with Java these days. So one of the main parts, which I do specialize in, is Android development. That is mainly done in Java, and as well you could build web applications through Spring Boot in Java, and there are so many more applications that it will take me years to get through all of the different applications. So I'll stop there. And yeah, Java is everywhere, and it's one of the most popular programming languages to date. So I'm so glad that you all are here to witness the beauty and greatness of Java. So if you want to download Java, it's a simple download. It's java.com, and you can download it from there. You could download it for Windows, Mac, or any sort of operating system. Well, later on in the workshop, we'll be using what is called REPL.it. And with REPL.it, you could compile code on the internet very fast, very easy. And you could create files and all of that sort for a whole bunch of programming languages. So if you want to test out the code and see what we're presenting is true or whatnot, make sure to go on REPL.it, make an account, and you could test your code along with us. You could also, if you prefer to use more of a traditional IDE, VS Code works great with Java as well. You might have to download the Java dependencies, or in the marketplace, just download Java. Other than that, should be simple enough to download. Also, if you guys by due chance have any questions during our workshop, what we're talking about, please feel free to leave them in chat or unmute if you have a question.
No, defeated.
Also, unless if you have a question, please keep yourself unmuted so we can go through the presentation. Thank you. Okay, so let's go ahead. So yeah, first of all, oh, I have a question. Why am I so cool? It's my genes essentially. It's that Trini blood. So shout out to the peeps back home. Okay, well, let's go into output. So, output. So essentially, when it comes to output, there are two main ways in Java to print out any sorts of information that you want. One of them is system.out.println, and the other is system.out.print. They sound pretty similar, they sound the same, but what makes these two different? Um, well, system.out.println. So the main difference between those two is the ln. Ln in this case for system.out.println stands for line, and when you call that function, or you essentially, or you write down that line, as soon as the as soon as you print a line, it'll jump. The compiler will join will or it will jump to a new line when you're printing out. So say that you're printing out hello. If you do system.out.println hello, and then system.out.println hello, I mean world, then you will get those two. You'll get hello first, and then you'll get world right underneath it. But whereas if you do system.out.print, you will get hello and you will get world smashed right next to each other. Um, and yeah, that's essentially that's how you print out those two statements. Let's go ahead. So next is variables. And Clement, you could your time to shine, brother.
Okay, sure thing. Okay, so now we're going to talk about variables. Before I get into like the first variable, I just want to explain what a variable is really quickly. To put it simply, it's basically just uh, something that stores memory or like information. And so in Java, variables are what we call are called strongly typed, because you have to declare what type it is, and you have to give some kind of assignment to it before you actually use the variable. Okay, so now we're going to get into the first type, which is a char. It's a single character. It can be a letter, a digit, a punctuation mark, a tab, a space. There's so many there's literally so many. If you want to look, you can like search up all the Unicode characters. Go have fun with that. And so here we have an example of initializing a character variable. So my char equals a. This creates a new character variable. And in Java, we cannot create an empty character because it's going to be, I don't remember specifically, but I think it ends up being null, and it causes like a null pointer exception.
Mhm.
And then, okay, so next slide, please. All right. So next we have strings, and strings are widely used in Java programming. They are simply just a sequence of characters. And so strings, you can initialize them using an empty string, or you can initialize them with like a word already in them. For this example, we just initialized it with two quotation marks, and this creates a new string. All right, next slide, please. All right, so strings can also be concatenated by adding two strings together. So when we see here is that we have our string one, that's hello with the space, and string two, which is world. And so greeting takes these two strings and then combines them into one hello world statement. All right. Oh, okay. And then next we have Java formatting strings using the string format method. And so what we do here with the string format method is we're going to add a %s symbol, which is basically going to serve as a placeholder for where we want to put the string that we want to use. So as you see in our example here, this is just purely coincidental, just a random string name called by Azhar's, and then we have a string course that does string format %s Java course, and then name. So the second we use the second argument name, the second argument here to show the string that we want to put in the placeholder position. And so then when we print out this string, it's going to say by Azhar's Java course. That sounds like a good idea.
I think
But
I would take up I'll take you up on that recommendation. I'm not gonna.
Yeah, I say buy Azhar's Java course all the time. You know.
Best source of medicine for anyone who is feeling the lack of Java. For sure.
All right, next slide. Okay, so string variables also have built-in methods like string.to lowercase and string.to uppercase. And I guess I could go a little bit off on a tangent here just to say like a strings in Java, like they're not actually primitives. They're like objects. So they'll have these different types of methods. And so as you see, as we go along here, you'll see like the other variables won't really be able to do something to have like methods like these. Anyway, going back to this. Uh, so we have string one that equals to buy Azhar's Java course. And when we pass it, when we run the function to uppercase, string two now has buy Azhar's Java course in all capitals. So I guess it's just screaming at you, trying to tell you what to do. But it prints out buy Azhar's Java course. This another coincidence, I swear. Next slide. Okay, so an integer in Java is simply a whole number, meaning there's no decimals or anything. And this is an example of how we initialize of integer variable in Java. And so you see here, int num equals 0. And with that, we create a number, a variable named num with an initial value 0. Okay, so in Java, there are multiple types of operations that can be performed on numbers. We can add to them. We can take the difference between them. This percent sign here is a modulus operator. And so when we do that, this gets the remainder if we were to divide two numbers. Then the star here is how we multiply two numbers in Java. And the last but not least, this slash is for division. Okay, so unlike some inferior language, Java does support incrementing using the using plus plus. So as we have here, we have int he equals to 34. And so on the next line, when we do he plus plus, this is like saying he equals to he plus 1. Listen, Lazaro, I promise you, you know who made this. And so when we print out he, the value will now be 35. Okay, next slide, please. Now, doubles in Java are decimal numbers, and they support the same math operations as an integer. And so to declare a double variable, we just go double num, and then we choose what we want to assign it to. If we were, let's say we didn't put like a decimal number into double, if we were to print out number, it would still come out saying 7.0 because by default, like doubles are like decimal numbers, so it's going to show up. And so, I mean, in this example, though, it's going to output 7.4. All right, next slide. Other operations like multiplication and division are also supported. And so here we have num1 equals 20, num2 equals 5. And when we multiply these together, we output, it gives us 100. And if we divide it, Azhar, we get 5.
What do you mean? 20 divided by 5 is 4.
Oh wait. Oh my god. I thought it divided and multiplied. I thought num1 divided multiplied. Oh my god. Listen. I major in computer science, I swear. Next slide.
He major in math. He doesn't major in math, so it's okay.
Yeah, I don't major in math, bro.
That's right. Acceptable.
Should have done Python. Nah. Okay, so the modulus operator is also supported in Java, and the modulo returns the remainder in division. So we have here when we do 17 divided by 4, it prints 4, and then when we do 17 modulo 4, it prints 1, because if we do 17 divided by 4, it equals 4 with a remainder of 1. And so we're going to get that remainder if we do the modulo. All right, next slide. Okay, the math class contains methods for performing basic numeric operations, such as elementary exponential, logarithm, square root, and trigonometric functions. So floor division is also supported in Java through the math.floor method. Floor division floors any number and converts it to an integer. So we have here, if double he, we have he, which is equal to 16 divided by 5, which prints out 3.2. But when we do math.floor he, it prints out 3, because it automatically just slices off the decimal number that we have. All right, next. You can calculate powers by using the math.pow function. And so we're going for the math.pow function, the first argument is the number that we're searching, the number that we want to put in. And then the second argument is the power to which we want to raise it to. And so here we have the number equals to 5 and the power is 3. And so this line just prints out 5 to the power of 3, which prints out 125. You're just realizing that now, Azhar. So, so for variables, integer conversion can be used on doubles. So this is called typecasting. This basically allows us to change the type of data that we have from one type to another. Typically, we would do it with going from a higher type to a lower type. And so we have here that the double set. Oh my gosh! Thanks.
No. I'm sorry.
So when we use doubles, typically, oh my gosh. Okay, so when we have the double, we have to have to typecast it to an integer, because technically a double is a higher level than a higher level than an integer. So I'm not going to go into too much detail about it, but in order to make a double into an integer, we have to typecast it. So in num, so we have here that we set num equal to the integer version of dub, which is going to make that into 19. And so when we print out num, it returns 19. All right, so double conversion can be used on integers. So the difference is with integers, since it's going from a lower class to a higher one, it's going to automatically become, it's going to automatically convert to a double, so we don't have to typecast it. So here we have this 19 and we set num equal to I, it becomes 19.0, and then when we print out this num, yeah, it returns 19.0. Next slide. All right. Booleans in Java are either true or false. And so we have Boolean to declare a Boolean. We just say Boolean happy. Well, we say Boolean in the variable's name, and then we can say that it's either true or false. So in this case here, we have happy equals to true. And so when we print out happy, it's going to print out true. And then when we set happy to false, it'll print out false. The next slide. Yeah, so setting a Boolean variable to true or false with a capital T or an F will result in an error. So we set Boolean cool equal to true, and then if we print out happy, it results in an error. Well, it's supposed to be T, whatever. Next slide. Declaration, declaration twice.
Because I put happy. There's happy twice.
Oh,
Imagine we weren't recreating happy again. Because imagine.
yeah. A variable can be given a Boolean value by comparing two values. So if we were to compare 5 greater than 10, this would return to us false. That's what we see in this first example here. And then in the next example, we have hey, and then we have a string. We have the string that's empty, and so and then we print out whether these two are equal, and that's false.
Mhm. That's also how
Yeah.
you could check equality between objects. You do the you have one object dot equals, and you place another object of hopefully of the same type, and you can check between those two to see if they're equal or not. Yeah.
All right. So using an exclamation mark before a false Boolean will result in true. That's because the exclamation mark is stands for a not in the Boolean logic. So if we set hungry equal to false and then we printed out exclamation mark hungry, this would result in turning that false into true. So it would return true.
Awesome.
All right. I'll pass it back to Azhar for functions.
Perfect. Thank you so much, Clement. So let's dive right into functions. So functions, before I get into how you make a function, what is a function, right? What is the purpose of a function? A function essentially is, so you saw how you could write variables and variables, right, of different types. But if you want to put those things together, right, if you want to put down multiple variables together or different commands together and store them, in a specific block of code where so you could reuse it again or have it set to do a specific sort of purpose, well, that's where you would put that stuff in a function, or also called as a method. So a function is declared using quite a few arguments in Java. So let's go through them one by one, and then I'll show you how you when you put all of those things together, what it would look like. So you first start off with either the private or the public keyword. So when you're creating a function, if you want that information to be accessible by other classes or by other users or to be used publicly, then you would write the function using, the public key word. But if you want that method, or if you want that piece of code, that function to just be only accessible within the class itself, not to be used by outsiders, then you would declare the function to be private. And whether if you would like the function to be static or not. So this is an optional sort of keyword, but depending if you want the function to be able to be called sort of freely when in terms of objects, then that's where you include the static, the return type. So there are multiple types of return statements that you can get. You could return back a string, you could return an integer, a double, or an array. You can return anything. But if you don't want to return anything at all, meaning that once you have your function, once you go through all of the calculations inside that function, if you want to get an end result, then that's when you would want to return something specific. But if you don't, then you could just name the method void, so that so that when the compiler is running that specific function, it's not going to expect an output from that function. Um, and then four, pretty important, the function name. What do you want to call it? Susan, Sally, to calculate area, that's what you would name it, and a pair of parentheses. So you have a pair of parentheses in order for the function to execute, and which you could put in, I'll get into this in a minute, but you could also place in parameters into those parentheses. And when you put in parameters in those parentheses, then the code will be able to take in specific input, specific information that it can use within the method. So let's take a look. So this is an example of a function that you can see. So we have our first function here. So this is also when I do have to stress on this really quick, since we're not currently running this on anywhere as a whole. Or sorry, we're not currently running this on REPL8, but if you're following along with the code and you're running this on REPL8, then this is how you would run the code, right? So when you're running the previous sort of functions or the sort of commands, you would have to run it on, you would do that stuff in the public static void main method. And when your code executes in Java, you run that information in the main method, which is where essentially the code, it will go through line by line and it will execute each statement. And if there are different classes that are being called, different functions, then the compiler will jump to those specific classes and call them, and that information will be passed back into the main method so that the code can properly execute. But when you're calling classes, or you're making different classes, you don't do this in the main method. You do this outside of the main method, methods. You do it outside the main method. So say you have your main method on top, you can place your methods on the bottom. Typically, the structure for when you're creating a Java class is that you have your variables declared on top, then you have your main on right below, and then you have all of your other functions declared after that. So that's typically how you write a class. But right here, we have our first function, which is called public static string greet. It's public, so it could be accessible by other sorts of methods. It could be accessed outside of this current class. String that's the return type for string. So we're going to expect that the method will return that specific variable. It will return a type of string, and it's not also important that it's not printing when it returns. It's just when we call the function, that's what will be like kind of replaced, or that's would be the end result of when you call it. I'll explain it better in a second. And then greet is in the name of it. So then we say return welcome everyone. So that'll be so we have here in the system.out.println, we call the greet method, and from there, greet will be called. It'll go inside the class and it'll say return welcome everyone. So technically, what's being written here, greet, will be replaced by welcome everyone. So it'll print out welcome everyone. Hope that made sense. Also, if you guys have questions, please feel free to let us know in the chat. We'd love to answer any questions you guys have. Also, so like I was saying before, variables can also be passed to functions, and these variables are called parameters. Parameters are what you pass into a function, and the function can use this information to return a specific sort of value based on what you input. So let's see. So public static int square int num, then you have return num times num. So instead of returning something absolutely specific, like let's say return 3 times 3, 4 times 4, this, when you pass in parameters, this makes your code scalable. So for any sort of input that you want to input into your code, you can use that sort of those variables, and you can return a specific value. I forgot to, for some reason, write what nums is, but assume that nums is 3 in the main method. And when you do system.out.println square num, again, so we have square num. So we're calling the square class, and we have num. It'll call that square class with 3 being inputted inside that method, and then what will be replaced by square num will be whatever return num times num is, which it will be 3 times 3, so that will be 9. Yeah, so that's how parameters work. Functions. So also when you create a variable inside of a specific method, that variable will only be accessible inside of that. It'll only be accessible inside of that method. So you can't access it outside of there, because imagine like it kind of exists in its own world, its own reality, right? So you create, you have your Greek class and you create a last name, which is Doe, and that last name is just in Greek, right? If you try to call last name in by, which is a totally separate method, it's inside the same class, right? But it's inside of its own method. This will result in error. It won't be able to access that last name. So that's something to keep in mind. But if you did want to access last name, so these are what are called like local variables, that they're only unique to a specific method. So we have a question from Hermes. So wait, could we pass last name into a by function and then it would work? Could we pass last name into by? Good question. So if we by chance had last name as a global variable, then it could work. So right now the variables are just within their own selves. If you pass last name into by, then well, not let me see. If you pass last name into by, where are you calling by though? Are you calling by, if you're calling it outside?
So wait, Azhar. So, my question was, you're telling us about the scope, right? So the string last name is not going to, you won't be able to use it in the bias string, right?
Mhm.
Right?
Yeah.
So is it possible if we leave the code just like that, but inside the by, in the parentheses, can we use that variable, or is it also outside the scope?
Oh, good question. So if you passed in, okay. Well, if you wanted to use by, right? If you wanted to put it in by, you would need to have by, you would need to allow by to take in parameters. So you would need to create, you would need to add an extra variable inside of that, those sort of parentheses for by, and in your Greek class, you would call by and pass in last name if you wanted it to work. Am I allowed to draw one? Doesn't seem like I am able to. I hope that makes sense. So essentially, you would you would change your parentheses for your by to allow for a string. You could call it last name. Actually, you would put string last name into by, and then you would have a by right here, and then pass in last name, and that will be perfectly fine. Yeah.
Okay, thanks. That helps out a lot.
Oh, of course. Glad. Thank you for the question. If anyone else has any questions, please feel free to leave in chat or speak up. Yeah, well, that was methods. now let's have some fun and talk about classes. So, what is a class, right? For those who may not know. Well, you have all of these methods, right? Um, wouldn't it be convenient if you could store all of these methods in one central place? If say you're building a person, or say you're building a square, if you have different methods, right? Like if you have an area method, or if you have a perimeter method, wouldn't it be nice to store all of these things in the same place? Well, um, thankfully in Java, that's totally possible. And that is what it's called, a class. So class is declared using class keyword, and which is followed by, or beforehand, right? You have either a private or a public keyword. Again, like I mentioned, it's similar to how private and public work in terms with methods. If it's a private method, just the methods, the methods aren't as easily accessible to to other sorts of classes, but public allows for, if you want to access methods inside that class, it's very easy to do that. So that's the difference between public and private. And then square is the name of the class that you are creating. So you yeah, so functions inside a class are called methods. So this public square, I'll describe it in a second, is a method, and this also area is a method as well. So we have, for this example, we have our square class, and then we have our main method. So imagine this stuff to the left is in the main, and the stuff on the right is, all of that stuff could be in the same class, but yeah, because I couldn't fit everything there in once. Assume they're in the same class. Um, but I'll dive down deeper into what each of these things are. So, a constructor. So, what is a constructor? Well, imagine you want to create. Let's say we have a square, right? You have an object square. If you want to define what this like what things are associated with a square, this is what you would use a constructor for, is to help build what the square is. So for instance, we have public square, where we say that a square should be defined by its base and its height. So and from there, we have this dot base and this dot base equals base, and this dot height equals height. So that's essentially saying that for this specific square, that's how you will be, yeah, at least for this square, your whatever is being passed, like the specific base, um that's what the value would be associated, that's what the value would be associated with. And this dot height equals height, for the height of this specific square, whatever you're passing in will be the height for that square. um So with an instance method or a constructor, this is a reference to the current. So again, yeah, this is what we're talking about with this. So this dot base, this dot height. This is a reference to the current object. So this current object that we have, that we're working with right now. Say we have a specific square, that's what we're working with. The object whose method is being called. So when let's say we're working with square here, equals a new square. So we're building a square. This in that moment will be referring to that square. So this dot base would equal 5, and this dot height would equal 6. But when you're calling, you're using that method, or sorry, you're using those variables, you just use base or you use height, outside of that constructor, or outside of that public square method, because yeah, you use it. Let's see. Definitely sure of that. No worries. Let's see here. A method inside a class could also be called by calling the method on the class or the class variable. So if you want to by chance use So let's see here. Yeah, system.out.println. If we want to, so we have this area here, right? We have this function. It's called public int area, and it's returning a base times a height. If we want to now say we're created a square, it has dimensions 5 by 6. Um, if we want to get an area for it, um, well, and a method is defined in that class for that specific thing that we want. Excuse me. Then we can just call square dot area, where dot is, the dot will allow for you to try to access any of the methods inside of that class. And area is one of those methods in that class. So you're calling that specific method, and which will return 30 because our area method is defined to have returned a base and a height. But now that we have covered the basics of a class, there's also something pretty cool as well, where you can get even deeper with classes if you don't choose. So let's say we have a square, right? Square is pretty general, but there's all sorts of different types of squares, right? But what if we wanted to create a cube, where a cube is essentially a square, but it also has, so a square has a length times a width, but a cube is a square, but in 3D. So, which means that it also has a depth going, sort of that way. So if we wanted to create this, and we wanted to say that the cube is a child of a square, or the square is a parent of the cube, then we say that the cube extends square, where well, why, right, why, okay, so we have that the cube is a child of the square. How does this benefit us? Right, why don't we just create them as separate variables, well, or separate classes? Why do we have to do extend? Well, if we do extend, then when we get some of the data that comes from being a square. But the beauty of it is that since you're a cube, you could also, or you're creating your own class, you can add your own functions or your own variables that makes you unique, or that makes you, you with the attributes that you're getting from your parent. And you can get the attributes that you want from your parent, and then you could use those attributes how you like, so that you could be your own self. So yeah, so classes can be extended by referring the parent class when declaring a new class. So methods in the parent class could then be called using super function. So what does this mean? So when we create a cube inside the constructor, again, a constructor being where you're actually creating the actual object for this variable or for this specific class. So for instance, we have a cube and right, public cube. We can essentially we can call the superclass, and it'll take um, whatever was called in the public square class. So for instance, we have this dot base equals base and this dot height equals height. When we call super, and since we passed also int base, int height, those variables will be passed into the super class, and those will be initialized for us. So we don't have to reinitialize them again. But depth, however, is new. So we do this dot depth equals depth, similar to how we would do this dot base equals base, this dot height equals height. We do this dot depth equals depth, and from there, yeah. So that's how that super function works. And you only use that when you're extending from a certain parent class. Perfect. So that's the scoop on functions. Now we're bringing back to Clem, or he'll talk about conditions. Take it away, bro. Oh, you mute.
Sorry. Okay. So now we'll head over into conditional statements. These will be the fundamental building blocks to how we like add logic into our code. Next slide. Yeah. So we'll be looking at the if, else if, and else conditional statements in Java. So an if statement in Java is written by using the if keyword. The if condition, if the if condition returns true, then the if block gets triggered. And so in this example here, we have number one, num1 is equal to 2, and num2 is equal to 3. And if we look here in this very first if statement, if num2 is greater than num1, then it's going to print out num2. Since num2 is 3 and num1 is 2, this is going to be true. And so we're going to print out num2. Next slide. Oh, okay. So the next conditional statement we're going to look at is the else if keyword. When you need to check several conditions, you can place an else if between the if and else block. So those would be like the equivalent to saying like or. It would be the equivalent to saying or. Like if you had one condition you were trying to meet and then you said or if it's this, or if it's this, or if it's this, that would be what else if is. So we in this example, now our num1 is equal to 4 and our num2 is equal to 3. So first, when we go into our block of statements, we go to the first if, and it's going to check if num2 is greater than num1, and this time it's not. So then it goes down to our else if statement, and it checks if num1 is greater than num2. And since num1 is 4 and num2 is 3, it prints out num1. Next slide. All right, and finally, we have the else statement. Else is used, it's like typically it's like the ending of if else block. I mean, you have to have you have to have an if to declare an else. Otherwise, you're going to get an error. So now here in this example, we have that num1 is equal to 3 and num2 is also equal to 3. And so when we go down our blocks of statements, we'll see that num2 isn't greater than num1 and num1 isn't greater than num2. So since none of these statements were true, then we're going to go to our else statement and we print out we have a tie. All right. And so now I'll be giving it back to Azhar to do loops.
Perfect. Thank you so much, Clement. So let's jump right into it. What are loops? Um, so a loop essentially, like I mentioned before, is a way for you to you could iterate through. So say you have a list of numbers, or say you have if you want to be able to count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But you don't want to necessarily count all numbers between 1 to 100. You don't want to create 100. What you could do, which would be way more efficient, or save you a lot of time, is if you create a for loop, and which will allow for you to go through each of those numbers. It'll automatically it'll jump to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it'll go for however long you want to go, and it'll do whatever specific action. And then you could have your logic based on when you're at this specific value or at this specific number, then you could do a specific action. So yeah, that's a general how a for loop works. For loops are usually definitely supported in all programming languages, really, except Pascal. I think they use recursion instead, which sounds terrible. I wouldn't try it, but shout out to Hamza for that. So a for loop in Java is declared using the for keyword and is used to iterate over a sequence, like I mentioned before. And for int I, so okay, so this is essentially how you create a for loop. So you have for int I equals 0. So you do int I equals 0. Essentially, you're creating a variable inside of that for loop that says like, okay, this is our starting point. We're gonna start at this specific number, right? And then you put a semicolon while for when I is less than some range, To be honest, this could be greater than, this could be some sort of conditional statement with I. But the main goal for this specific part is logic on our and to know when to stop the for loop. Because if you don't have this, the for loop could possibly go on for forever. And typically you are doing, when you have a for loop, you want to have a start and you want to have an end. So you declare the start at the beginning and you declare the end, which is like at what point it should end. And then I plus plus. So this could also be I plus equals 2 or I equals I plus 1, I equals I plus 2, all of these specific ways. But this is essentially telling you how big your steps are that you're taking when you're going through the for loop. So when you're going through all the list of numbers from 1 to 100, it's going to be I plus plus or I equals I plus 1. Those are the same thing like Clement mentioned earlier, because you're going to want to iterate, or you want to touch each number as you're going through. But let's say that you want to only touch evens, right? You only want to pick the numbers that are even. So since you're starting from I equals 0, technically even, what you would do is you would do I equals I plus 2. Or a shorter way of doing that is I plus equals 2. And that would allow for you to get, so you would go from 0, then you would do 2, 4, 6, 8, and so on and so forth. Yeah, that's this sort of normal for loop the general for loop. There's also a type of different for loop, which is called a enhanced for loop. An enhanced for loop allows for you to basically, say if you have a specific data structure that you want to go through, say you have an array, you have a hash map, or a string, it really could, it depends, for int number in array. So depending on, say this array is an array of integers, you can specifically go through each number in this array. And actually when you're doing inside your for loop, number, you don't have, okay, instead of having to access, right, like when you're doing accessing in an array, which you'll find out later more about, you'll have to do a specific, whatever you're naming your array with a bracket and at that specific value, whether it be I, whether it be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But instead of having to do that in an array, you actually just work with the number itself. So that, in essence, is the same thing as your array at a specific value. Because yeah, you're going through each specific object more or less in your array. That's what a foreign enhanced for loop allows you to do. So let's take an example here and go through a for loop real quick. So since the for loop in Java iterates over the strings, yeah, multiple things that you could iterate through. For instance, here we are given a string, which is apple, and we're given an array, a specific array of numbers, which is 1, 2, 23, 4, 5. What we'll have, so we start the array at 0. So this is our starting point. Then we say that we should stop when I is essentially equal to the string, the string dot length. Otherwise, you know, it will keep going through the string. And keep going by intervals of 1. So essentially go through each element in the string. Then at each specific point, for every value of I, we'll print out the array at I. So whatever I is at that specific point. So when we first start off, I is equal to 0. So we'll first print out 1 plus, or you know, when this is in terms of concatenating strings, str1.char at I, where char at I will be at that point at 0, it'll be A. So we'll first have 1 and A at that point. And then if we go on, then it will be 2 and P, 23P, 4L, and 5P. Yeah, and that's how it'll go through that step by step. And then once we get to the end of the array, once we get to outside of the loop, or the outside of the length of the string, it will check this conditional statement. I is less than str1.length, at that point it should actually be equal to the length. Because remember, in programming languages, when we index or when we are accessing a specific variable or accessing a specific index, will start from 0. That's very important if you're just getting into programming. Most of them will. It's different than traditional counting, because you start in counting, you do 1, 2, 3, 4, 5. But the way how data structures and counting is set up in programming languages, you start from 0, 1, 2, 3, 4. So which is why we do less than str1 dot length when we're starting at I equals 0. Um, so those are for loops. But there's also another way that you can iterate, which is, if you ever see me do competitive programming, I for some reason really like while loops. I find them way more convenient. But a while loop essentially is created using the while keyword, and it will run a block of code inside um that method, or that while the condition inside the parentheses is true. So we have, of course, our beautiful while loop here. Boolean Java is the best language. While, that's true. Um, and while Java is the best language, true, we will keep printing out that Python sucks. And we'll see that we actually don't create a statement where this will ever stop, and it should never stop because this will always be true. So for eternity and in beyond, this will keep printing out Python sucks, as it should be. Um, does anyone have any questions? Oh, I see some comments in the chat, not necessarily liking that. I am sorry for that you feel this way, but you have entered the Java workshop. So there's also you could get even more specific with while loops. There's also what is called a do while loop. A do while loop is similar to a while loop, but the main difference is that it will run through the first iteration regardless of what the while loop's condition is. So this is different than a normal while loop in essence, because depending on what the conditional statement inside the while loop could be, if the while loop might not even run at all. If that, right, say we have I is equal to 10, and we say that while I is less than 10, well, I is equal to 10 already. So that loop, the while loop will never run. But in this statement, I is equal to 10. So in this case, while I is less than or equal to 10, I plus plus. So regardless, since even though that technically is false, it will do that I plus plus once at least. So I will end up becoming 11, and then it'll check that I is less than 10, but it's already false, so it won't run it again. But it will run it once, which is different than a normal while loop because it won't run at all. Yeah, that is those were for loops, and those were for each loops, while loops, do whiles. And now to sort of end up this sort of part of our presentation, Clement will take it off and we'll go over the data structures, including arrays and hash maps. Take it away, bro.
All right, so for this last part of the workshop, before we get into creating our fun little game, we're going to touch a little bit on data structures. To put quite simply, data structures are just ways to manipulate and organize data. And so what we have here for you guys, first, we're going to be going over arrays, and then we'll get into hash maps. So we have arrays. Arrays in Java are simply a list of objects of the same type. So here's two examples of declaring an array and an array list. So we'll have the type of array it is, and then with the variable's name, and then we declare how big it is. And then for the array list, we have these things called wrapper classes, but it's pretty much the same. Like for the most part, they have the same name as like your regular data types. Just like it's small things, like for integers, you have to say integer instead of int, and like for the majority of the simple data types, like you'll have to capitalize the first letter. There's nothing major. and then yeah, you just you name the variable whatever you want, and then you instantiate it, new array list, and that's about it. That's how we go about initializing them. Next slide. All right. So arrays can be used in for loops to iterate over each element. And so here we have the array declared with the values 1 through 7. And so in this for loop, for each element in the array, it's going to print out each element in the array. Pretty simple, just going from the beginning to the end. Just to go over the enhanced for loop again. So this int item is going to be element coming from this array. So we don't have to necessarily go. We don't necessarily have to say array at that specific index. So because item is going to already be that element. Next slide, please. Okay, so specific elements in a list can be accessed through indexing. And so we have here, we have an array and we have an array list. That for loop is just to add all of the items from the array into the array list. And so we can randomly access elements inside of an array. So here we get the first element in the array list, and then we also print out the third element in the second array and in the array. All right, next slide. So what's the difference between arrays and array lists? Arrays are very similar in terms of their operation, and the only real difference between them is that one is static while the other is dynamic. Arrays, uh, arrays are considered static because they're a set size. So once you fill up all of the space inside of them, they're not going to resize. If you try to add something else, you're going to get an error. While when you use array lists, as you fill, this is like the equivalent to like what lists are doing in Python, but they don't tell you. But as you fill up the array, once you've completely filled up the array, if when you try to add another variable, it's going to create a copy of the array that's doubled with all of the previous elements, that's double the size, so that you can keep on adding to the inside of the array list. So it's a little bit slower, but it gives you that advantage to keep adding as many elements as you want. Next slide. And so now we're going into hash maps. Java hash map, a dictionary for you Python people, is an unordered collection of items where each item has a key value pair. Hash maps are, yeah, similar to dictionaries in Python. And like Azhar said in the chat, yeah, by far the best data structure. So important. Like, I don't know if any of you guys are like in programming 2 or programming 1 or whatever, but just remember the name hash map. Yeah, they're super important for technical interviews. Exactly. And so here we set up a hash map of string integer map. So the key is going to be a string and the value is going to be an integer. And so in the next line, we set up a key that's Java and a value that's equal to 1. And then and then the next line we have Python, and we set the value equal to 0. And so when we print out map.getJava, it prints out 1. A dictionary value can be accessed similar to indexing a list, but instead of a number, the specific key is passed. So, oh yeah, so pretty much we can access values directly from their key names. So yeah, so directly from their keys. So that allows us to randomly access things at any time, just like how we did with arrays, which is super convenient and very fast. And in this example here, it's pretty much the same thing. It's just showing that once you call the key, when you get the key Java, it's going to print out 1. Yes, sir. O of 1 get, the power of the hash map. All right. When accessing a key value pair that does not exist in Java, it's going to throw an error because it doesn't exist. So you're going to be trying to call to a key that is uh, essentially no. And so what we see here, it's basically the same thing again. We add Java and 1, Python and 0, but this time we try to get the key, we try to get the value from the key CPP, but we don't have that anywhere. And so it's going to return a null pointer exception because there's nothing pointing to that specific place to where CPP is. Next slide. So the keys and only the keys of a dictionary can be returned using the key set method on a hash map. So when we run this, okay, so when we run the key set function, this allows us to iterate through the keys. Now, remember, this isn't a way to iterate through the keys in order because, like we said earlier, hash map, the way that hash maps work is that everything's going to be thrown in randomly. And I don't want to really get into the details, but there's cases when things are thrown into the same place and it deals with that within the data structure. That's a discussion for another time. But yeah, so this allows us to access to the keys in random order. And so in this example here, we just set for each string key in the key set, it's going to print out the key.
And this is an example of what I was talking about earlier, where an enhanced for loop. You'll get these a specific string object inside the map, and it will print out that string object instead of having because you don't know specifically what like Clement is mentioning, you won't know specifically where in the hash map things are because they're kind of just there's more to it, right? They're like hashing and all of that. So it'll just print out like some key based on its hash value.
All right, and so the values and only the values of a dictionary can also be returned using the values method of a dictionary. And so again, we're doing an enhanced for loop. So this is going to get each value from the map. So it's going to get the 1 and the 0. I don't know which one it's going to get first because, like I said, very random. We can't predict it. So it would either print out 1 and 0 or then 0 or 1.
Oh yeah, sorry, it's supposed to be 0 and 1. Apologies.
Just ignore it. Just ignore it. just ignore it. And so yeah, that does it for the data structures. And just one more thing to add in. Can you go to the next slide? Facts. All day, every day, now and forever.
Yeah. You know how they have those nice quotes at the end of PowerPoints or yeah. So this is by the end, this is what we want to leave you with knowing. In conclusion, based on what we have shown you about about Java, Java is better than Python, and this is quoted me and also Clement today.
Yes.
So Clement, do you want to jump to like the next slide, or do you want to jump to what we had in?
I mean, let's get started on the extra thing we had planned.
Okay. I'll stop sharing my screen so you can share your screen.
Okay, okay. Oh boy. Oh my. All right. So we are going to make a game in Java. Just a simple rock, paper, scissors game. Uh, it's going to hopefully, yeah, it's going to use pretty much everything that we've covered today. Uh, so yeah, this should be interesting. Uh, all right, so we're going to start here. We're going to first create a player class. So let me just get rid of this. Um, that's the name. The name of that string is just coincidence. I promise. All right. All right. So let's create our. Oh, wrong thing. Yeah. So let's create our player. So our player is going to have. We'll just have our player have a name. Our player is going to have a name, and our player will also. He'll keep his own score. Because why not? And we're also going to create something where we can add to a score. We'll create something so that we can reset the score. And we have to make sure we also be able to get like their name or their score. Okay. And so let's get started. So first we'll create something called a constructor, a constructor. So basically, this is going to initialize the player object, kind of like like if we were to create a variable with the player, we would have to provide certain parameters in order to initialize this. And so that would be a string name, and then just a name, honestly, because I almost forgot. We're going to create some global variables. Oh, let me see the chat. Oh, I can't see the chat. Oh, programming one class. IntelliJ blows it away. I 1000% agree.
I definitely agree as well. Also NetBeans and blows away NetBeans as well, which is commonly what you would probably use for programming one classes at FIU.
All right. So before we get into the constructor, let's create our attributes, which from what we've described here is basically going to be the name and the score. So we create a name. Oh my gosh. And then we're going to create a score. Oh, yeah. And so the reason why I've declared these as private is because of something called encapsulation. And long story short, we don't want random people able to touch our private parts. Okay, so uh, we're going to, so now going to the constructor, we create when we create this player, we're going to set the name equal to the name that we get passed in. So all this is doing is like it just references the specific instance. So the thing that we're whatever variable we're initializing at this time. So that would be what the name. It would be the name for this initialization at this time. And so then we're going to set our score equal to 0. And so we have to create an add score, and that is just going to add 1 to the score using score plus plus from what we did with incrementing. And so then we're going to create the reset score. Oh, and this just sets our score back to 0. Typically, like, let's say if the game, yeah, like if the game ends, we just set our score back to 0. And then we also want to be able to get our score. So let's say we play multiple games with another player and we want to see who wins. We'll have to be able to get both of their scores in order to decide it. So then we return the score. And so next, we're going to get the name. And then finally, we're going to create the choice, which will be used for when we start implementing our game. And so what we're going to do for this is we're going to import a library. We're going to import the utils library. Because we need two things. We're going to need a scanner to take in a user's input, as well as be able to create a hash to use our hash map. So we're going to create a scanner object instance. Use scanner system.in. So that creates a scanner object. And so then we're going to create a hash map of integer and string. So what I'm going to do with this is I'm basically going to prompt the user to choose 1 for rock, 2 for paper, 3 for scissors. And then afterwards, they'll be able to choose their number, and then whatever number they choose, we return it. And that's how we're going to decide what the player's move is for that turn. So we put in 1 and then rock, and then we put in 2 and paper. Oh my gosh, I'm a CS major, I swear. And then we put 3 and scissors. Okay. And so then we're going to prompt to the user to choose 1 for rock, 2 for paper, and 3 for scissors. So we'll print out choose 1 for rock. And then we're going to do something called an escape sequence. So there's space in between each option. 2 for paper. And then 3 for scissors. All right, and so then we're going to do something in the scanner, something with the scanner object called .nextInt that allows us to take in input from the user. So we'll create an integer choice and set it equal to in.nextInt. So whatever number that the user chooses inside of out of the 3 options will end up going into choice. And then afterwards, we just return map.get choice. And so based on one of these three choices, it's going to, yeah, based on whatever choice the person chooses, it's going to go into the map and return the choice that they selected. All right. And so now we can go into coding out the game itself. So let's head over to game.java. All right. And so then we're going to create. So now we're going to put two players in here, player one and player two. And we're going to create two methods. Uh, we'll have we'll have one that runs the game. So just we'll call it play, and then we'll also have one that's pick winner that will choose the winner for any given round. And so for here, we're also going to have to import a scanner because we don't what's it called? In case like the player wants to keep playing, we'll deal with that as well. So we'll just import all of utils just in case I wanted to use like an array or something else again. And so we're going to create our two players. There are two attributes, player one and player two. And so then in our game, when we initialize our game constructor, uh, we're just going to go here, uh, player one, player two. Set the player one of this game object equal to player one, and then set the player two equal to player two. So now we have two players in our game, and so we're ready to create the two methods that essentially are going to run our game for us. Okay, so now we're going to create the method void start game. Well, we'll just call, yeah, we're going to call public void play. We're going to add a scanner object here because we want to be able to, because we're going to have an input for whether whether the players want to play again or not. And so now we're going to create the string play, which is going to be taking in that input. And so we'll set that equal to y, just so that right now it will be a yes to continue playing and have more fun. And so while play, so we're going to run a while loop. So while play does not equal to n, we're going to have two choices. So choice one is going to equal to,
Clem,
yep,
that play might be better as a character than or if you're gonna do equality like that, do dot equals instead.
oh my God. Oh my gosh. Yeah, that was I'm a CS student, I swear.
You're a pro Java developer. It's okay.
Yeah,
So,
yeah. Nobody saw. All right. And so we're going to set choice one equal to player one's choice. Yeah, so choice one is going to be player one's choice. And then we're going to make another variable, choice two, that's also equal. That's equal to player two's choice. All right, really quickly, I do need to see whether I actually named it this choice. Yeah, okay. It's just choice. Good, 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 good. And so let's head back here. And so now string choice two is going to equal to player two dot choice. And so now we're going to set an integer winner, and it's going to get the result from the pick winner function that we're going to make. So int winner equals to pick winner choice one and choice two. So we're going to leave this here for now, and then we're going to go and create our pick winner function. So before we go into it, I'm going to say that for our pick winner function, 0 is going to equal a win for player one, and a 1 is going to equal a win for player two. Okay. So now let's create it. So we say public int pick winner, and we take in the two players' choices. And so now our first thing is going to be if player one chooses rock and player two chooses scissors. And then that's going to be a win for player one. So let me just say now what I'm basically going to do is I'm going to cover every case where player one wins, and then I'm also going to cover every case where there's a tie. And if it's not where player one wins or it's a tie, then I'm just going to return that player two wins, because that's the case. So the next case when player one wins is when the choice one is scissors and the other choice is paper. So we said if choice one equals to scissors, oh my goodness, scissors, and choice two equals to paper, then we're going to return 0. Sorry, it's supposed to be an else if. Okay, so then we're going to return, and then we're going to do if if choice one equals paper and choice two equals rock, and that's going to cover all of our cases where player one wins. Choice two, rock, Then we return 0. Oh, whoa, what's going on up here? Oh, that's weird. Okay, so now we're going to handle all of the cases where we have a tie. So that's going to be when they're both paper, when they're both rock, and when they're both scissors. So I'm just going to copy one of them just so this moves by a little bit faster. Oh my gosh, what happened?
There at the end of line 34, replace the P with the beginning bracket.
Oh goodness, nice save.
There you go. Yep. Perfect.
We good? We're good. I think I have to add one more here just to. Yep. All right, we're chilling. Okay. So, if choice 1 equals paper and choice 2 equals paper, we're going to return 2. And so the reason why we're going to return 2 is because when we get back into the play function, we're going to check to see if winner is either 0 or 1 to add to the player's score. And whoever and so if it's 0, then it adds 1 to player 1. If it's 1, it's going to call to add to player 2's score. And then if otherwise, it's not going to add to anybody's score. So then again, we're going to set if choice 1 equals to rock and choice 2 equals to rock, then we're going to return 2. And then last but not least, if choice 1 equals to scissors and choice 2 equals to scissors.
In addition, you could also do whether if the two strings equal each other, then you could also return 2 as well. There's multiple ways of doing that as well.
Yeah, that's true actually. Yeah. I mean,
The same thing.
yeah, there's multiple ways we could have went about this. And so if it's not any of these cases, then we know that the other player won. So now why is it crying? Okay. I mean, I could technically just go like this and then. It's okay. Let's just ignore that for now. Okay, so then we're going to come back here, and whatever we get from this function here, we're going to say if winner equals 0, then we're going to add 1 to player 1's score. So I have to see what the method is real quick. Add score. Yep. Okay. So player 1 dot add score, and then we're going to check if it's not equal to 0, then we check if it's equal to 1. Otherwise, we're not going to do anything at all. Well, we can just have two if statements like this. the need for an else if statement there really. Okay, and so then afterwards we're going to prompt to the players if they want to play again. And we'll say Y for yes and N for no. And so then we'll allow them to make a choice. Hopefully they follow instructions and just do Y or N, because otherwise it's going to keep playing again regardless. And so afterwards, we can
do a validation loop. No balls.
Oh my God. Are you kidding? Oh my God. That's one extra while. That's one extra while. I'm not trying to just. Oh my gosh. We're keeping it really basic. Okay. So then once we get out of there, we're going to print out who wins. So that's just going to be comparing player 1 and players 2 scores. So if player 1 dot get score is greater than player 2 dot get score, we're going to print we'll say player 1 dot name is the winner. And then if player 2 has a higher score, we're going to say that we'll say that player 2 is the winner. We just borrow that line here. Is it? Oh wait, I have to see. Is it? Make sure I'm calling the right. Okay, get name. Back here. All right, and then finally, we're going to check if, well, otherwise, we're just going to print out it's a tie. And so I just typed out like 100 lines of code. So let's see if this runs on the first try. We're shooting from half court right now. Okay, so we'll create 2 players. Equals new player. Let's say Azhar. And then we'll have me. And then wait, Azhar, are you still inside? Are you still in this?
Should have I have access to it.
Oh wait,
Not currently.
oh, okay.
Yeah,
So
I'm
then
in it right now.
Oh wait, but then we'd be able to see our own moves, so it doesn't matter. Never mind. So now we initialize the game. And let's see if this runs first try. Okay. Oh wait, I didn't make a choice. Oh, okay. Yeah, there we go. Yeah, something went wrong. Cannot find symbol in player. Oh, okay. That's all? That really it? Okay. So now let's see. Is it okay? It's taking a lot. Oh, I didn't. Oh my gosh. There we go. We didn't call play. That was oof. Okay. Here we go. All right. Choose one. And then player 2 chooses 3. Oh, we didn't show who wins for the round. But let's say we press N. It says Azhar is the winner. I mean, so yeah, we created a rock, paper, scissors game. So that's going to conclude it for our workshop. Thank you everyone who stayed until the end. I really appreciate it.
Yeah.
And
And
oh, go ahead.
let me share my screen really quick so you can catch all the information about us. So Java is better than Python. Got to reiterate that one more time again, as Clement beautifully showed. Thank you so much, Clement, for showing. And we'll also be uploading that on our GitHub as well. So if you're in our DSC server, which you'll get access to now. Oh, also, I sent the link, the resources. I sent the slides for the for you guys that wanted it. I could send it again in a second. We also, for those that want to dive deeper into Java and learn more about it, you have some compiled resources here that you can access. We have Python documentation as well if you just want to see how disgusting Python is and then want to get back into the Java code. We just left that there beautifully for you guys. But other than that, we have left all of the other Java, how to get started, tutorials, and all of that sort. Yeah, so thank you so much from me, from Clement, and the rest of the DSC FIU team, as well as thank you so much for AIS for giving us this perfect opportunity to talk about Java. And I hope that all of you got something out of this workshop, or if you, whether you're new to programming, new to Java, or whether this was a refresher for you if you have learned Java in the past, I hope this was beneficial for everyone. And yeah, at least on DSC side, this is what we have upcoming. We have our GitHub workshop happening tomorrow, which is being taught by Lazar Hurtado, our vice president, will be teaching this GitHub workshop. So if you want to learn how to make the proper, how to use GitHub properly, and look a little less confused at work, definitely join in our GitHub workshop happening tomorrow. We'll be collaborating with UPE at 8 p.m. on Friday for a trivia night, where you could win some awesome prizes and test your brain a little bit, but not too much like you're in class. And on Monday, next Monday, we'll be having our resume roast happening at 7 p.m. on our Discord, which you can access here on go.fi.edu/DSC Discord. And yes, you'll get also access to our Instagram and our website for more information as well, where you'll also see like our sign up form and all of that stuff there. So yeah, thank you all so much for coming, and I hope you all had a great time.